Chapter 7. Force and Pressure. Quick Fiend Focus. Force. Effects of force. Type of forces. Pressure. Liquid pressure. Atmospheric pressure. You know that for doing different jobs like lifting school bag, opening a door, squeezing tube of toothpaste, kicking a football, pushing a box etc., a force is needed. Thus, a force is required to move an object, to change speed, direction or shape of the object. Force. Force is a push or pull on an object which changes its state of rest or motion. The force applied on an object can be large or small. Force is denoted by the letter F and its C. Standard International Unit is Newton, N. When two objects interact with each other, then a force acts. For example, the door of your room will not open unless you apply a force to pull it with your hands. Here is an interaction between the door and your hand. A bicycle moves when you apply force on its pedals with your feet. Here also your feet interact with the pedals. If two persons apply force on an object in the same direction, the resultant force is the sum of two forces. Thus, a cart pushed by two persons will move faster than when it is pushed by one person. If two forces act on an object in opposite directions, the net force acting on it is the difference between the two forces. Activity 1. To study the effect of force on an object, pull a trolley with your friend in the same direction, Fig. A. Then, let only your friend pull the trolley in any direction. Fig. B. In which case does the trolley move more distance? Next, let both students pull the trolley in opposite directions, Fig. C. In which direction does the trolley move? Discuss with your friend. Effects of force. To move an object or to stop a moving object, one has to push or pull it. Force can produce motion. A stationary object moves by applying a force on it. Force can be applied on an object either by pulling it or pushing. For example, you need to pull the door of a car to open it. Similarly, you have to push the door to close it. The object moves always in direction of force. Try to push a table. You can move it easily from one place to another because the force applied by you is sufficient to move it. But when you push a truck or wall, it does not move. Here the applied force is not sufficient to move them. Thus, sufficient force is needed to move an object. Force can stop a moving object. A force can be applied to stop a moving object. You must have seen a goalkeeper stops the ball using the force of his hands. He applies a force opposite to the direction of moving ball. Force can change the direction of motion. A force can change the direction of motion of an object. You must have seen a batsman hitting a ball with his bat. By doing so, he is changing the direction of ball with the help of force applied by his bat. A very small force can change the direction of moving object. Remember, what happens to the ball when a batsman just flicks it over the slips? Sometimes it goes for a long distance even when the force applied is very small. Force can change the speed. The force can also change the speed of a moving object. If force is applied in the direction of motion of the body, the speed of the moving body increases. However, if a force is applied in the direction opposite to the direction of the body, its speed reduces. You can slow down or stop a cycle by applying brakes or pulling it. Force can change the shape and size of an object. A force can change the size and shape of an object. For example, the shape of dough is changed by applying force to make chapati. Similarly, The shape of rubber band is changed by stretching it. Activity 2. To study the effect of force on different objects. Take some or dough used to make chapatis. Apply force to change its shape in different ways. You can easily do it. Next, take a toy car and a cricket ball. Apply force on them, trying to change their shapes. Is it possible? No. Force has different effects on different bodies. Try these. Write true or false. 1. Force is a pull or push that acts on a body to change its state of rest or motion. 2. If two forces act on an object in opposite directions, the resultant force is the sum of both the forces. 3. Forces are due to interaction between the object and the applied force. 4. To move a body or to stop a moving body, you have to apply force. 5. The unit of force is joule. Type of forces. Forces are broadly classified into two types: contact force and non-contact forces. The further classification of these two types of forces is shown below. Force. Contact force. Non-contact force. Muscular force. Frictional force. Mechanical force. Magnetic force. Gravitation force. Electrostatic force. A. Contact forces. The forces which act directly in physical contact with objects are called contact forces. Let us discuss different kinds of contact forces. Muscular force. The force exerted by muscles of the body is called muscular force. It is applied to lift an object, to swim, to ride on a bicycle, and to do many other such activities. Workers use muscular force to carry goods and horses use muscular force to pull carts. Frictional force. A force that which opposes the motion of an object arises due to contact between two surfaces is called frictional force. It slows down things or prevents them from moving by action in an opposite direction of motion of a moving object. For example, when you stop pedaling a cycle, it stops after moving some distance. A ball rolled on the ground stops after a short distance. Mechanical force. The force applied by a machine is called mechanical force. B. Non-contact forces. The forces which act on a body without any physical contact are called non-contact forces. The different kinds of non-contact forces are: magnetic force. The force exerted by a magnet is called magnetic force. You have learnt in previous class that magnets attract metals like nickel, iron and cobalt without coming in direct contact with them. Activity 3. To study the effect of magnetic force, different materials. Take a magnet and some materials made of iron, cobalt, wood, plastic. Bring a magnet near these objects one by one. Observe the ones that get attracted towards the magnet and bring it close to the first magnet. Identify the north and south poles of the magnets, keeping in mind that like poles repel and unlike poles attract each other. Electrostatic force. The force exerted by a charged object on another object is called electrostatic force. Just like a magnets, like charges repel and unlike charges attract each other. Activity 4. To observe the effect of electrostatic force. Place tiny bits of paper on a table. Take a plastic scale and rub it on dry hair, 10 to 12 times. The scale gets charged. Bring the charged plastic scale near these bits of paper. The bits of paper get attracted to the scale due to electrostatic force exerted by the scale without touching the pieces of paper. Gravitational force. The attractive force which any two objects exert on each other is called gravitational force. Every object lying in a room exerts a pulling force on the other. They also exert a pulling force on a person present in the room. You cannot feel the pull exerted by a table because its mass is not sufficient to apply enough gravitational force. But you can feel the gravitational pull of the earth because the earth is very big. The earth's gravitational force attracts all objects towards itself and it keeps us bound to the earth. Any object thrown in the air falls back to the earth due to the earth's gravitational force. The earth revolves around the sun due to the sun's gravitational force. A gravitational force always attracts objects. Have you ever measured your weight? Does it remain same everywhere on the earth? The weight of an object does not have same value on the poles and on the equator. Weight is also a force. The gravitational force exerted by the earth on our body is called weight. As the value of gravitational force changes at poles and equator, weight of the body changes. The balance used to measure weight actually measures the force exerted by Earth on the body. A spring balance and electronic weighing machines are generally used to measure weight. A spring balance measuring weight of a stone is shown in the figure. The common physical balance used by hawkers measure the mass of an object that you will learn in higher classes. Let us perform an activity to find the weight of a body using spring balance. Activity 5. To measure the weight of objects using spring balance. Take a dozen of banana, school bag, cricket bat and 1 liter pack of milk. Hang the objects one by one from the hook of the spring balance and hold it in air and wait till the marker stays. Note down the reading. Find the weight of all objects and write in the table. Object weight in kilogram. A dozen of banana, school bag, a cricket bat, 1 liter pack of milk. Try these. Answer these questions in short. 1. What is the force exerted by a magnet called? 2. Name the force that opposes motion. 3. Which type of force is applied by a machine? 4. Name the force applied by the muscles. 5. Name the force which attracts two objects towards each other. 6. Which force is exerted by charged bodies? Pressure. The force acting per unit area of an object is called pressure. It means the pressure that we apply on an object depends on force as well as the area of contact. Have you ever seen your mother cutting vegetables? Carefully observe the knife. You will find that sharp side of knife is used to cut vegetables. If you try to cut them from the blunt side, you have to press harder in comparison to the sharp side of the knife. Now try to press the blunt side of a pin from your thumb. You will find that the sharp end of the pin penetrated through the paper easily. On the other hand, it is difficult to penetrate a pin from the blunt side into the paper. Why is it so? In case of a blunt knife and a blunt pin, the area of contact is more as compared to sharp knife or a sharp pin, and thus we have to apply larger force. Pressure is calculated by the following formula. Pressure equals force applied by area on which force acts. The SI unit of pressure is Pascal, Pa. 1 Pascal equals 1 N per square meter. Thus smaller the area of contact, larger is the pressure exerted. This principle is applied in making pillars of bridges and flyovers. Pillars of bridges and flyovers have a broad base, so that the pressure due to the heavy weight of the bridge gets distributed on larger area and is bearable for the ground. Trucks and buses have 6 to 10 broad tires. These tires increase the area of contact on which their weight acts. This reduces the pressure on the ground. That's why some big trucks have 8 to 10 pairs of double tires. Similarly, foundations of high-rise buildings are kept wide so that they exert less pressure on the ground and do not sink due to the high pressure. Activity 6. To show that pressure depends on area of contact. Take two nails of the same size, one pointed and the other blunt. Take a wooden block and a hammer. Hammer the head of each nail into the wooden block with the same force. Which nail pierces into the wood more easily? Of course, the nail with the pointed tip, because the force applied is on a lesser areas as compared to the nail with the blunt tip. Solved examples. Example 1. Calculate the pressure exerted when a force of 60 Newton is applied over an area of 15 meters square. Solution. Force equals 60 Newton. Area equals 15 meters square. Pressure equals force divided by area equals 60 Newton divided by 15 meters square equals 4 Newton per meter square, or 4 Pascal. Therefore, pressure equals 4 Pascal. Example 2. A man exerts a pressure of 10 Pascal by applying a force of 80 Newton on an object. Calculate the area on which this force is applied. Solution. Force equals 80 Newton. Pressure equals 10 Pascal. Pressure equals force divided by area, or area equals force divided by pressure equals 80 Newton divided by 10 Pascal equals 8 meters square. Area equals 8 meters square. Pressure exerted by liquids. You know that liquids do not have a definite shape, hence the pressure exerted by them depends upon the depth of the liquid column. Liquids exert pressure not only on the base but also on the sides of the container. Let us perform some activities to understand this. Activity 7. To show that the pressure exerted by a liquid at the base of a container depends upon the height of the liquid column. Take a glass tube that is open at both ends. Fix a rubber balloon at one end of the tube. Hold the glass tube with the balloon facing downwards and put some water into it. You will observe that the balloon starts bulging outwards. Pour some more water in the glass tube. You will observe that the balloon bulges even more as the height of the water column increases. This proves that the pressure exerted by a liquid at the bottom of a container depends upon the height of the liquid column. Higher liquid column exerts more pressure. Activity 8. To show that liquids exert the same pressure in all directions at a given depth. Take a tin can and make 3 holes in it at the same height. Close the holes with cello tape. Now pour some water in the can and remove the cello tape from the 3 holes. You will observe that water comes out from all the 3 holes with the same force and falls at the same distance. A tin can with holes around it. Activity 9. To show that the pressure of a liquid increases with the depth of the liquid. Take a tin can and make 3 holes at different heights. Close the holes with sellotape. Pour some water into the can and remove the sellotapes. You will observe that water from the topmost hole comes out with least force and falls at the minimum distance away from the can. The water from the lowest hole comes out with greatest force and falls at the maximum distance. This proves that liquid pressure increases with the depth of the liquid. A tin can with holes at different levels. Since pressure of liquids increase with depth, deep-sea divers wear special suits. These special suits protect them from the increasing water pressure. Activity 10. To show that pressure at any point under a liquid is due to the weight of the liquid column above that point. Take a tub full of water. Try to push a balloon filled with air down into the water. The balloon resists the push into the water because the force exerted by water on the balloon is much more than the force exerted by you. Thus, the upward force of water resists the downward movement of the balloon. Pressure of liquid column below the balloon exerts upward pressure. Atmospheric pressure. The atmosphere around us, which is a mixture of gases, exert pressure on all objects. The pressure exerted by the atmosphere on an object is called atmospheric pressure. The atmosphere exerts large pressure on us. So, why don't we get crushed under its weight? This is because the pressure exerted by the blood in our body is equal to the pressure exerted by the atmosphere on our body. Thus the effect of atmospheric pressure gets nullified. Activity 11. To show the presence of atmospheric pressure. Take a glass tumbler and fill it with water up to its brim. Take a cardboard sheet and place it over the mouth of the tumbler. Place your hand over the cardboard and quickly invert the tumbler. Now, slowly remove your hand that supports the cardboard sheet. You will observe that the cardboard sheet does not fall because the atmospheric pressure on the cardboard is much more than the pressure exerted by the water on it. A glass with water covered with a cardboard sheet. Glass containing water in inverted position. The atmospheric pressure depends on the altitude a place. The atmospheric pressure reduces as we go higher altitudes. As you go higher up on mountains, you will find that your ears pop. This happens because the air pressure around your ears decreases, causing an imbalance between the pressure inside and outside your ears. Mountaineers often suffer from nose bleeding at high altitudes because the pressure exerted by the blood in the body becomes much higher than the atmospheric pressure outside. Effects of atmospheric pressure. Let's discuss some effects of atmospheric pressure. On pressing a rubber air sucker, the air inside it gets removed and the atmospheric pressure from the surroundings keeps it stuck to the wall or almirah on which we hang light things, such as key rings. You must have heard about squids. They are found deep under the sea where the pressure of water is too high. When they are brought to the surface, their bodies burst. It happens because the blood in their bodies flow at very high pressure, which cancels the effect of pressure exerted by water on their bodies. At the surface, the outside pressure decreases and their bodies burst. Similarly, if an astronaut goes into space without wearing spacesuits, his body bursts. Astronauts wear special spacesuit to maintain a normal atmospheric pressure for their bodies, as there is no atmosphere in space. Try these. Answer these questions in short. 1. When does the pressure increase and decrease with respect to area of contact? 2. On what factors does the pressure exerted by liquids depend? 3. What is atmospheric pressure? 4. How does liquid pressure vary with the depth of liquid? 5. Why do your ears pop as you go higher up on mountains? 6. What is pressure? Quick recap. Force is a push or pull on an object. The SI unit of force is Newton. Force acts when two objects interact with each other. Force can move a stationary object, change the speed of a moving object, stop a moving object, change the direction of a moving object, and changes the shape and size of an object. Force is of two types: contact force, muscular, frictional and mechanical forces, and non-contact forces, gravitational, electrostatic and magnetic forces. Pressure is the force acting on a unit area of a surface. Its SI unit is Pascal or N per square meter. With the increase in area of contact, the pressure decreases. When the area of contact decreases, the pressure increases. Liquids and gases also exert pressure. The pressure exerted by air on the objects is called atmospheric pressure. In liquids, the pressure exerted increases with depth is equal in all directions at the same depth.